Yes.
Start with the history of a diamond blade. For those of us that aren't used to, the power tool world, what is a diamond blade and how is it made?
Well, the diamond blade kind of started out in the first part of, the last century. So, early in the 20th century. Before that, there were abrasive blades. So it was kind of a meld of abrasive material like they used for cutting metal and things like that. And they had masonry ones that would cut concrete, but they wore out very, very fast.
Okay.
So the technology came that they could put diamonds in the segments, and that's, I'm going to use a blade here. This is the segment, and they were able to embed the diamonds in there into this metal matrix. And then they would use silver solder and kind of weld or solder the segments onto the blade. So which means they had to use water to cut. And it kind of came out of the, through the 50s and 60s when they were developing microchips and things like that, they were using these blades. So it was a real high-end technology
at
first and not affordable. So as time went on, of course, it became much more affordable, and they started using it into construction and cutting concrete and masonry and brick type products.
So that brings me to you saying that now that it's affordable, there's probably a jump in quality, correct?
Yeah, the technology is developed so that there's huge savings in the quality, and also in then mass production brought the prices way down, and so now it's a very accepted thing. And then in the 80s, they started laser welding. Again, that was kind of a new technology to laser weld the segment onto the core, and that allowed you can eliminate the water. And so that kind of started out the whole dry cutting scene. So
that kind of leads us to our IQ blades. Can you talk about, why did we develop IQ blades?
Well, we've had blades for many, many years, but one of the things we decided to do several years ago is actually come up with the Q-drive arbor. And here's kind of the arbor, and you can see our blade has a Q-drive arbor so that we could really control the blades being put on our machines. And the reason we were doing that is because previously we had machines and you could put any blade on it. And the problem we were having is people will go buy these cheap blades and put them on our machines, and then, the machine's not working correctly, or maybe they get a real cheap asphalt blade and they're trying to cut something that's not appropriate. So we decided, what, as we developed our machines and developed the technology, blade selection is critical to the success of the whole machine. Because, the bottom line is if your blade is not cutting, it doesn't matter about what the rest of the system is doing. So
makes sense.
So we spent the time and did a tremendous amount of testing to develop these blades and match them to the horsepower of our machines, RPM of our machines, the different type of material. And we're continuing to do that testing every day. Actually, probably in a few minutes, you'll hear a saw running. We're testing right now.
All day. He's not kidding.
All day long.
So you kind of touched on it, but can people put other blades on our saws?
Yeah, so we have, most of our machines use the Q-drive arbor, but there are manufacturers out there that have gone and changed the Q, because this is proprietary. The Q is, we have it patented, we have a trademark, so it belongs to us. But there are companies out there that have made some other different types of shapes, and so they'll accept, a different blade. So they can go to a different manufacturer and buy a blade. But I can tell you, we spent hundreds and thousands of hours testing and developing these blades for that specific machine, RPM, horsepower, amp rating. So these other companies are just, producing these things and taking their best guess and putting these things on the market. And they're using you guys as guinea pigs to do the testing. So, so you can go buy these blades. You may or may not have some success with them, but I could tell you the worst thing is you put the wrong blade on a machine, and now you're overloading that machine because it's not cutting well. It's just putting too many amps, too much load on that machine, and now you're going to start breaking components. So it's we really tried to keep our blade pricing very competitive, so you're not having to pay much more or any more for our blades. So we would really recommend that you stick with the IQ blades, and you're going to have the best results.
So just want to interrupt real quick. Anybody that's new and just joining us, Sarah and Paul here with IQ Live, and we're talking all about blades. If you guys have any questions, totally interrupt us and we'll be happy to answer those questions. So Paul, you've touched on testing a little bit, but I think we would like to show kind of what's going on back here and dive into a little bit of testing. What do you mean by we do our own testing?
Well, there's no other way to do it but then to get a machine out and start cutting material. And as we developed the tile saw blades, we did thousands and thousands, tens of thousands of cuts to develop the tile saw blade. And what we do, for example, this is the new blade for the IQ 228, which is the 7-inch tile saw blade. And so we will take this blade, and after we have tested, maybe, 12, 13, 15 blades, I don't know how many we ended up testing to develop this one. We have our logbook here, and we'll take a blade, we'll make 100 cuts, we'll measure how fast it's cutting through a specific amount of material, what is the diameter when we started, and then after 100 cuts, what is the diameter? And so we're measuring those things, and we measured this particular blade all the way down to where it was completely worn out. You can see this has no segment left. And we got 4,400 plus blades, so 4,400 cuts. And these right here are the actual cuts. This is what we were cutting. It's just some, cheap red ceramic tile, but we did, over 4,400 cuts and wore that blade out. And at that point, we decided we had a good combination. This is a good, blade life for the end user. So that's how we do it. So lots and lots of testing. We test all of our blades. And like I said, we're currently testing blades right now. So developing blades for all the different types of materials out there is a real challenge because, there's, tens of thousands of different types of materials, man-made, natural materials, synthetics, all kinds of things. So as new things come on the market, we have to get that product and basically just start cutting it up and developing a blade for it. So
we get a lot of questions, and I feel like these questions kind of flow right into testing. And we test to find the answers for these. So one of the common questions we get all the time is, what is causing my blade to warp? And what does that mean? What does that look like?
Warping or wobbling is when the blade has lost attention. And we have a blade here that I could show you. Blades, a lot of times you'll see this ring around here. That's the tensioning ring. Blades are made to spin at a certain RPM, and they need to be tensioned to spin at that particular RPM. If not, they will start wobbling because they're just, a piece of flat sheet metal, and normally that's, real wobbly. But what the tensioning ring is it kind of puts a wrinkle in it and kind of stretches it out and strengthens it so it will hold, its flatness as it spins. So what happens when it loses the tensioning? Typically, the end user has the wrong blade for the application, and he's pushing really, really hard because he thinks, well, the blade's not cutting, so I'm going to push harder. And what that does is actually is bending that blade, and the blade is kind of, reacting to that force, and then it loses its tension, and then it really starts wobbling all over the place. It can be actually kind of violent in certain situations. But so it's kind of a combination of things. If a blade has lost tension, it's usually because they're not using the right blade for the application. And so that's kind of a clue. If the blade is not cutting, pushing harder does not make it cut better. That actually is going to cause problems. What it means, if you're pushing, that means you got the wrong blade for the type of material you're cutting. So you need to back up, analyze the material you have, and see what blades are available to cut that material.
So if my blade has lost tension, what do I do?
There's nothing you can do. Once
can't get it back?
tension, yeah, you can't get it back.
Got it.
And that's a real shame because if you got segment left, the blade would still be cutting if it's using for the right material. Because you see here's a blade that's almost completely worn out. You can see the segments on this are almost completely gone. And that's what you want. You want to wear those segments out. This is 10 millimeters of segment. And here we're worn down to, about 2 millimeters. And that's what you want. That's how a good blade should look, that's wearing properly. So
when you talk about segments, can you tell me what is in a segment and what does the cutting? Is it the diamonds? Is it the metal? What are we looking for?
well, it's both. So if you look at the metal matrix here, this is the segment right on the edge. And you can see within that segment, there are diamonds. And what they do is they take these different metal powders and put them into a little form, and then they add diamonds into that form with the metal powder. And then they press it and they heat it at the same time, and that basically melts that metal powder, and then it suspends those diamonds within that powder. So that's how the segments are made, and that's the critical point, is understanding what metals are in that segment so that they wear away at an appropriate speed to expose fresh diamonds to cut whatever the material is you're cutting.
And does that, I guess, that mixture make a difference versus a hard material versus a soft material? You've talked to me a lot about the different kind of bond that creates and what bond to use for what product.
Yeah, that is very important. Basically, you want a softer bond material to cut harder material.
That always confuses me.
Yeah, so you want soft bond to cut hard material. And the reason for that is the soft bond will wear away faster. The metal matrix wears faster, exposing
More diamonds
faster. And it's the diamonds doing the cutting. The metal matrix basically are there to suspend the diamonds and release the diamonds at an appropriate speed so that you're cutting the material. So selecting the right blade is really critical to the successful cutting.
Okay. So I'm just going to interrupt again. If you guys have just joined us, this is Sarah and Paul with IQ Live, and we're talking all things blades. Please leave a comment if you think we're doing a good job or if you have questions, and we'll definitely answer those for you. So we want to kind of dive into a little more about the technology. We've talked about the segments and the diamonds, and how they're made, but can you maybe talk a little bit about arrayed diamond placement versus random and kind of how that all works together?
Yeah, so there is the arrayed diamonds, which you can kind of see if I can pull this up closely. I don't know if you can actually see it, but these are actually arrayed diamonds, and they're actually, in a pattern. And let's go to the whiteboard. Can we zoom in on the whiteboard here? So random diamond segments basically just are that. In that metal matrix, the diamonds are just put in there randomly, and wherever they land, they land. And then they're exposed at the appropriate level. When you have an arrayed diamond, they have a new technology now, relatively new, that actually stacks the diamonds in rows and kind of lines them up like soldiers, I kind of liken it to, so that when these diamonds wear out, there's a second line of diamonds right behind it. So it's a real organized approach to the cutting. So that's the difference between arrayed and the pattern or random.
And is there really a benefit to a specific kind of material that would do better with arrayed versus random, and vice versa?
Yeah, there is a mix, and it really comes down to your metal matrix here and what you want to be using. And sometimes random, a diamond is actually better. Actually, random can do better on harder material because there's a little bit more slip to the machine, especially on lower powered machines. Random can do a little bit better in some cases. So it's really doing the testing and figure out what is the best application. So
perfect. Okay, so another technical question we get quite often is, what is a flange and how does it help cut?
What is a flange? So a flange on a blade, for example, we employ the flange on the blade, which is a step here. So the blade is actually thicker in this section here, which keeps it more stable as it's cutting, and that allows us to have a nice thin cutting edge and keeps it stable while we're reinforcing the center. So that's what a flange.
And what's the benefit of having the thinnest cutting line possible?
Well, you can imagine, the thicker this is, the more energy it takes to cut through the material. So the thinner we can make this, takes less energy, and it's a more precise cut. And that's really important when you're cutting tile.
Okay, very, very interesting. And I know we have that on our new porcelain blade as well, correct?
Yes, we do. We actually, on our 16-inch blade, we've had a step because we really wanted to thin down that segment and cutting surface to get through that really hard porcelain.
Got it. Another question that we get for most of our masonry saws is how do we keep our blades so quiet?
So quiet? Well, we have what is called a quiet core or silent core. Sometimes they're called laminated. So a normal diamond blade is just a steel core. This is just all steel. And if you hit it, it sounds like a bell. And when this thing is spinning, it rings like that. It is very, very loud. So what we do is take and sandwich two outside steel cores, and we put a laminate. Sometimes it's copper, sometimes it's different materials.
Big difference.
Yeah, big difference. And that deadens the sound almost by 50%.
Wow.
So it really makes them a lot quieter.
Very cool. Yeah, I bet you that makes a big difference on the job site for sure.
Yeah, just, being around one of these machines, instead of, the blades running at 120, 130 decibels are running around 100, 105 decibels. That's a huge difference.
So our tools are different, obviously, because we're anti-water. So how do we keep the blades cool? Because I know heat can create an issue with diamond blades.
Yeah, well, like I said, that technology that came in the 80s with laser welding, allowed us to take our masonry and concrete blades and cut dry.
Yes.
So that's been available. What we really had to develop is in the tile industry. You're cutting porcelains and very, very hard material, and cutting dry is very, very difficult. So we spent a lot of time developing our blades with the flange, with the thickness, with the metal matrix and the right diamond concentration, so that the blades are cutting really, really well, and that eliminates friction, and that keeps the heat down.
And I know the vacuum system, right, also helps.
Yeah, so we're actually, with our dust collection system, we're generating vacuum, and that is also pulling the grit away, and it's also air cooling the blade. So it works out very well.
I think they probably want to see a cut and see the proof in the pudding.
Okay.
You want to make a cut?
Yeah, let's make a cut.
So we have the combo blade on here, correct?
Yeah, so this is just a combination blade we have on here for our tile saw. So we can make a cut here. Can you shoot and see the...
Can you guys see that? It's kind of small, but right now it says 74.
74.
Went all the way up to 80.
Then all the way up to 80. Typically, even if you keep on cutting, you're going to be 10 to 15 degrees over the ambient air temperature. So it stays really cool. You can grab the blade. It doesn't heat up. It's not throwing sparks. But while we're talking about that, it is important to dress your blade. And we can talk about that a little bit more, but you take a dressing stone, and basically it's kind of like brushing your teeth with a, you're using the dressing stone to open up the diamonds, expose fresh diamonds so that it's cutting. So if at any time your blade stops cutting and it feels like you're needing to force it, get your dressing stone out, sharpen it up, exposes fresh diamonds, and then you're good to go. Because you should be wearing that blade, that segment, all the way out to nothing. And that's how.
And when you're talking about exposing new diamonds, let's show them that cool photo that we have about the microscopic picture of the blade. When you say that you're losing diamonds, you literally mean you're losing diamonds and need to expose new diamonds.
Yeah, and that's really happens when you're like using a tile saw, you start cutting different types of material. So if you look at this picture here, you see these little pock marks and those little dark marks. That's where diamonds were. And a lot of times what happens is when you kind of go from a softer material to a harder material and back to soft, the blade is kind of conditioning itself to the material you're cutting. And so it's kind of exposing the diamonds that, for the type of material you're cutting. So here we have no diamonds and the blade won't cut. So let's go to the other picture and show you after you use a dressing stone, And now you can see those diamonds are exposed, and the diamonds are what is doing the cutting. And also interesting, right behind the diamonds, you see what looks kind of a comet trail. And that's the backing behind the diamond, and that's holding that diamond in place as it's being pushed through the material and doing the cutting. And that's very, very important. And again, what happens is you start cutting different types of material and switching to different materials. It erodes that comet tail, and then the diamonds pop out. So you need to use a dressing stone, expose fresh diamond, and you're back in business.
Yeah, these pictures are pretty cool. I remember when you showed me this for the first time under the microscope. It was pretty cool. So about dressing the blade, what can they use to dress the blade?
Well, like I showed, you have a dressing stone. If you don't have a dressing stone, sometimes it's just taking some abrasive material, like this is cinder block or CMU. You can use something like this to expose the diamond. So it's really kind of using something that's very abrasive to wear the metal matrix back, exposing fresh diamonds. So.
And for everybody, we do have multiple videos about dressing the blade online on YouTube and our Instagram and on Facebook. So if you ever have questions about dressing the blade, either reach out to us or definitely just Google it. And I promise IQ will pop up and you can watch that video. So we talked about the dressing stones. Oh, good question that we get a lot. Can they use a masonry dressing stone on a tile blade and vice versa?
Yes, they can. But if you have a tile blade, you really want to use a tile-specific dressing stone. But you can use a masonry on a tile. It will work. It's just the best is the right.
And you say, I know that the masonry stone and the tile stone have different grits. Does that have anything to do with it? And what does that really mean?
The grits, it's like, sandpaper has different grits. So the dressing stones have different grits, and the grits are made to match the grits that are in your segment, and so that it's made to sand back or expose the diamond from the metal matrix.
Got it. And what do you mean by conditioning the blade?
Well, a lot of times when you get a brand new blade and you start cutting, it may not, want to cut real well. Maybe it chips a little bit. What we recommend is take that brand new blade, make 15, 20, 25 cuts. And what it does is it's opening up, it's conditioning to the material you're cutting, and then your diamonds are getting set. You're setting that backer or that comet tail behind the diamonds, and then it'll be a nice smooth cut. So give the blade a little chance to open up and condition.
Yeah, because I know that we have a lot of contractors who say that our blades do better the more they cut with them.
Yeah.
And that has to do with conditioning, correct? Yeah. Excellent. So just again, anybody that's joining us, Sarah and Paul, IQ Live, and we're talking all things blades. If you guys have any questions or comments, please put them in the chat and we will get to them. So we kind of want to segue and talk about our specific blades and our products. So with our line of blades, how do you pick the right blade for your material?
Well, let's go over to the blade table here and we can kind of talk about that a little bit. So for tile saw, we have 3 different blades. We have the combo blade, which is your general purpose. We have the hard material blade, and then we also have a soft material blade. So we have 3 blades for the tile saws, depending on the type of material. Then for our 362, which is our masonry saw, that machine can cut a lot of different types of material, from man-made to natural stones, and so it can be all over the place. So we've developed what is the combo blade here. This is our black blade, and that's for cutting your abrasive material, kind of your standard pavers. So that's a great combination blade. But as you start going into like a harder brick, we have the hard brick blade here, which again, we talked about those bonds. These are getting to be a softer bond. And then we have some specialty paver products kind of around the country, like in the Northwest, certain parts of around Indiana, Ohio. They have some really hard aggregates in those areas. And so that requires, a softer bond blade to cut those types of materials. And then, of course, we have we're calling the porcelain blade, but it's kind of a next level of hard material, because porcelain, this is becoming really popular. It's actually 20 millimeters thick, or over 3/4 of an inch thick. It's porcelain. This is 42,000 PSI incredibly hard material. So we had to develop a specific blade to cut that, and it has a thinner segment. It has that stepped flange to stabilize it. And so making sure you have the right blade for the material you're cutting is critical.
So I know we get a lot of back and forth, honestly, between the orange and the gray blade. So I don't know if you could just really hammer it home, the difference between those two in particular.
Yeah, these two in particular, again, this is really for your harder brick and for smaller, hard product. When you get into larger concrete products, your larger format pavers that are hard, you want to go to the orange blade. So you can kind of drive it by the size of material, helps a bit. But also this is really for your larger concrete products, and this is really for your hard brick. So.
Okay, this might be a dumb question, but I'm gonna ask it anyway. Why can't I use a 16.5-inch blade to cut little regular tile, like a subway tile?
Well, these are designed to cut large material, and you can see the segments are pretty aggressive. And that's really the difference. If you look at a tile saw blade, let me go grab the tile saw blade. One of the things with tile, it's a more delicate medium. And so we had to develop a cutting segment that's, does a chip, relatively small, and then it kind of glides through that material. These are much more aggressive for fast cutting, and this is for more delicate.
So really the continuous rim, we didn't even touch on that. Continuous rim versus segment blade, it kind of goes like that. If it's a more delicate material, I need a continuous rim blade. Is that what I'm understanding?
Not in all cases, but yes, typically continuous rim is going to give you a smoother cut. So. Got
it. So I know that that's a new fancy blade you got in your hands, and not many people know that that's out yet.
Yeah, this is our soft marble blade. So this is one of the areas that we had some people, we were getting feedback, and they wanted a blade for cutting for marble. So we developed that, and we did, again, thousands and thousands of cuts to get to a blade that will cut marble successfully. So.
What other materials besides marble would that be good for?
It's usually very soft. There's travertines, which is in the marble family. There's limestone, which is kind of in that softer type of materials.
So I know, especially with marble and some other materials, sometimes you get a little bit of chipping or a little bit of a rougher cut. How can I fix that situation?
Well, simply we have a new product. For example, let's go back to the desk over here. So for example, I just made that cut, and you can see this is porcelain. It's a very acceptable cut. But a lot of guys and craftsmen use those rubbing stones. And so we've kind of upped that and used a diamond pad here, which cuts through that porcelain really fast. And you can just kind of come in here and take that edge off. And then when you grout it, it looks nice and smooth. So this is our diamond dressing pad here.
And those are available now, correct?
They are.
Excellent. Okay. That's pretty much all the questions I had from me and from what we usually get from our Facebook audience. Do we have any lingering questions online, Evelyn?
No.
We pretty much answered everything?
So far, so good.
Excellent. Well, just again, to wrap up, everybody, Sarah and Paul with IQ Live, we were talking all things diamond blades. If you guys ever have any questions about blades, reach out to us. We have our service department with Bill and Kevin. We have our customer service team or any of our dealers. Happy to help you guys. Remember to dress your blade and pick the right blade for the right material.
That's the critical piece. Make sure you got the right blade for the material you're cutting, and you'll have a good success.
So thank you, everybody, and follow us on social media for our next live video next week. You guys have a great weekend.
Thanks, everyone. Have a great day.